All right, radius. We are familiar with the term radius because of a circle. And so if you'll look at, specifically look at this one right here, we have this square inside the circle. You will notice that if I take the center of the square and go all the way to a vertex of the square, I hit the circle that it is inscribed in, inscribed meaning on the inside, okay? And so in a polygon, a radius of a polygon is going to be from the center to a vertex. These are all radii, from the center to a vertex. We are going to be calculating just regular polygons, so every radius is the same length, okay? Every radius is the same length. So you'll notice when I drew all of the radii, I had the same number of triangles that I have sides. This is a pentagon. When I drew my radius to each one of the vertices, I had 5 triangles for a pentagon, all right? That is your radius. It is from the center to a vertex. All right, this creates what's called a central angle. Central angle. That is the angle that is created at the vertex. At the center when you draw the radius. Central angle. You'll notice I had 5 central angles. They will all be the same size, okay? So if I want to find the measurement of my central angle, you take 360 and you divide by how many angles you have, in this case 5. So if I want to find the measure of these angles for a regular polygon, I'm always going to use 360. You can see that it created this little circle here, and I'm going to divide by how many I have. That's just the number of sides. Okay, that's how you find your central angle. All right. The last term is one you probably have not used before this, and it is called an apothem. An apothem. That is from the vertex, but it does not go, it's from the center, but it does not go to the vertex. It goes perpendicular to the side. That is the apothem. Goes from the center to the side. Apothem. We are going to use this to calculate area. So you need to know what it is and what the difference is between that and the radius. All right. So let's look at just first finding the angle measure. All right. Look at example 1. Example 1. All right. The theorem here says the radius of a regular pentagon divides the polygon into congruent isosceles triangles. To find the central angle, 360 divided by n. 360 divided by n. So example 1, how many central angles will I have? Well, that is going to be based on how many sides I have. So how many sides do I have in example 1? How many sides do I have? They want me to find the measure of the central angle. To find the measure of the central angle, that's this guy right here, I'm going to say 360 divided by 8. It's going to give me 45 degrees. 45 degrees. Everybody see that? All right. They want me to find a base angle for this triangle. So we're going to take this triangle, and they want the base angles. They told me this creates an isosceles triangle. What do I know about the base angles of an isosceles triangle? They are what? They're congruent, all right? What do all angles in a triangle add up to? 180, all right? So if I know the top guy is 45, I'm going to take 180 minus the 45. That's going to give me 135. And then I just divide it by 2 because I have 2 base angles that are the same. I'm going to get 67.5 for both of those. So I know this guy is 67.5, this guy is 67.5, and the central angle is 45. Okay, that is important because we are going to use that to solve for area. All right. So let's look at the next issue here is theorem for regular polygon. So basically what I create is I create all of these triangles, all right? So what's the area of a triangle? Well, the area of a triangle is 1/2 my base times my height. 1/2 my base times my height, okay? In this case, for my central triangle here, my height is my apothem. So my apothem is my height. Everybody see that? The apothem is the height of that triangle there. My base is one of the side lengths of my regular polygon. Well, how many do I have? Well, I have as many as I have side length, right? As sides as I have. So in this case, I have a certain number of sides here. I have 8 to be exact, 8 sides, and they've given me one of my side lengths. Well, I could add it up 8 times. I could say, well, I'm going to say 1/2 base times height, and I'm going to multiply that by how many triangles I've created. All right? But what you can do instead, because it's regular, is you can take the perimeter of your regular polygon, perimeter. And that's where we come up with the area of a regular polygon. This is a formula you must know. The area of a regular polygon is going to be 1/2 your apothem. All right, that's your vertical distance from your center to your side. It is the height of that central triangle that's created. And you are going to multiply that by the perimeter of your regular polygon, because that's basically adding up all your triangles. Just take your perimeter, all right? Just take your perimeter. So let's look at this one. They have given me the apothem. The apothem here is 12.1. 12.1. I'm going to plug that in. 1/2 my apothem. All right? Did they give me my perimeter? Did they give me my perimeter, the entire distance around? No. What did they give me? 1 side length. What is my perimeter then? Yeah, it's 80. Why do you know that, Kai? There we go. You take how many sides you have times one of the sides. That is your perimeter. Okay? So when they give you the side length, just multiply it by the number of sides you have. That's your perimeter. And then plug it in. You have 1/2 times 12.1 times 80. All right? So the area of this particular polygon is going to be 584 square centimeters. 1/2 apothem times perimeter. You have to know that formula. 1/2 apothem times perimeter. Just plug it in. So in this case, they have given me the side length. So I can easily find my perimeter by taking the number of sides that I have, which is 6, times my side length, which is 24. So I have the perimeter. My problem is they did not give me the apothem. They did not give me the apothem, all right? So I have to calculate my apothem here. Now here's what I'm going to do. I am going to first figure out what this central angle is, all right? What is this central angle? That's important. That's important for me to know. So to find the central angle, I'm going to say 360 divided by my number of sides. What is my central angle? 60 degrees, all right? Now let's pay attention to what they have done here, all right? This is an isosceles triangle, and they have drawn a dotted line from the vertex down. That is my apothem, okay? If this is 60 angles, that should have cut that in half, all right? That should have cut it in half. So that means this small angle here is going to be 30. So I'm going to pull this triangle out, all right? I have a 30-degree angle here. I have a right angle here. This has to be a 60-degree angle because it has to add up to 180. I have a special right triangle. Does everybody see I have a special right triangle? All right? So now I'm going to look at just this guy right here. So I'm looking at just this half of this right here. Just this half. All right? I have a 30, 60, 90 triangle. All right, 30, 60, 90 triangle. It's beautiful there. All right, 30, 60, 90, all right? It also cut my side length in half. So if my side length was originally 4, what is this piece of it right here? 2, yes, all right? I really need to find the apothem. That's all I'm missing for my formula. In a special right triangle, if my shorter leg is 2, what is my longer leg in that special right triangle? That's my hypotenuse. What's my longer leg? 2 square root of 3. This is 2 square root of 3. So I now know my apothem. My apothem is 2 square root of 3. All right? And I have everything I need to solve this area. I am just going to plug it in. 1/2 perimeter, that's my 24, times apothem, that's my 2 square root of 3. They want a rounded amount here. So that means in your calculator, you do 0.5 times 24 times 2 times the square root of 3. And you will get 41.6 square inches. So you are going to potentially be using special right triangles to find either the apothem or the side length to help you find the area of these. So I want you to try one of these. Try one of these. In this case, pay attention, in this case, they gave you the hypotenuse of your special right triangle. The hypotenuse of your special right triangle. So you're going to use that to solve for your side length, or at least half of your side length, and your apothem to get perimeter in order to get your area.